Welcome everyone. My name is Pete Presti, and just wanted to share with you my sawmill project that I've done over the wintertime. I just regret not videotaping anything during the progress of it. We just recently moved from New York. I call it escape from New York. And we went to Pennsylvania, built a new house out here. And in doing so, when they cleared the lot, I asked them to leave me all the logs. They're beautiful wood out here. It's all white oak and beautiful hardwood. Very little pine though, no, very little pine. All mostly white oak, and I got a huge pile of it. Some of them are like in 20 inches in diameter. It's going to make some nice lumber. I started milling last year when we first moved up here. We're here about a year, and I milled my first couple of logs. I bought the mill from Frontier. I bought an OS23. My only regrets with that, I wish I would have went with the next size up, but I didn't, and I got the 23 and started looking at some YouTube videos about people milling, and there's some very interesting things that people are doing with these mills today. And so I got an idea in my head, so why don't I just automate my own? Stand by. I went out to Home Depot and I bought this rigid tool case, and it actually worked out well. I was able to pack everything in here that I needed. I got all the outputs that actually go out to the mill right here. You have this would be the sensors and brakes. This would be main power. This one here would be for the blade up and down, and a couple more sensors that I have coming through here, along with some supporting power. Here on this end here, I have another connector for. Like I said, I went crazy with this thing. Another connector for a wireless remote, which is here. That remote is actually what they use for cranes on ships and warehouses. You know, they have those big cranes that move around these big containers and stuff. Basically, it's a pretty simple thing. We'll run through that later. So here I have the controller. We have main power. I used two pulse width modulators to control the motors. The reason why I use these types, because these were really nice, because it had where you can control the speed of the motor, which was very nice. How, you know, depending on how hard the log is, will determine how fast you want it to go through the log without getting those waves in the log. So here you have forward and reverse. That's now the machine is looking to move forward. In the home position, it'll come home. By the way, I can when you put it in any one of those positions, when it reaches the end, there are sensors on the tracks that sense that the head is at that point, and it shuts that motor down. The same thing with home. This is your blade up and down. I don't have sensors on that because I feel that the only time you're turning this on to go up or down, you're actually monitoring it, so you know how high it, is too high or how low is too low. Then we have, here we have a switch for the throttle. This throttle switch does two things. It throttles up the engine, and in that state, it also opens an electrical valve for the water lubricant on the blade. With the engine in the idle position, of course the blade is stopped, you don't need the lubrication, the water shuts off. So you have throttle up, and then all the way is throttle down. Now the reason why I have this type of switch is a lock switch. It's a toggle switch. It's a two-position toggle, but in the center it actually locks, so you can't accidentally hit that either way. You don't want to be working on the blade or something and or cleaning it, and somebody comes by and accidentally turns that blade on. It's going to cause a little damage. So that's why I used one of those type of switches. Here you have, I can control the water valve if I want to do it water on auto, which means now the throttle controls when the water comes on, or manual. If I put it on manual, then without the throttle going up, the water will flow. And the reason why I did that, sometimes you get a kink in the line from moving back and forth and you don't know where it is, so you put the water on and you play with the hose, and then eventually, you find it starts running, it starts flowing. But anyway, I don't know if that was necessary, but I thought it would be a neat thing to do, so I did that. The two flashing lights you see happening here, that is indicating that I have the brakes on both motors applied. In that state, either motor will not work. What I did was I put in two power relays to sever the power, the main power going to those motors with the brakes on. So you can't, it won't go forward and it won't go reverse, or the blade won't go up and down with the brakes on. If it did, the problem I was having is without that circuit in place, not realizing the brakes are on, stupid me would put it in forward, and guess what? 25 amp breaker pops like that. So I did that a couple of times before I decided, you know what, I gotta do something to tell me to turn those brakes off. So I came up with this little system. So now the brakes are on, nothing will work. So if I take brake, motor 1 is my blade up and down, motor 2 is forward and reverse. So now I took the brake off of motor 1, now this will come in play. Blade up and down will now work. And the same thing with forward and reverse. The brake is on, it is now off, telling me that the brakes are off, and now this will work, the forward and reverse. So that's how I set that up. So now I also I wanted to do the wireless remote, like I said. So, and I wanted to be able to choose what I wanted to remote and what I didn't want. So that's where these switches come into play. So you have a power switch to turn the remote on, the receiver on, and then here you have my blade, forward and reverse, throttle, and water. Right now everything is set for local, so which means all these controls are active. Once I set them to remote and turn the power on, this now becomes active. And let me demo that, how that works. So here we have the wireless remote module I built, and that simply plugs into the side. I got all of these connectors are all waterproof. That box is all waterproof. I'm sure I'm going to get caught out in the rain. every once in a while, and I just didn't want to have to worry about that. So I went ahead and spent a little extra money on the waterproof connectors for that reason. So now I have, let's get this over here like this. Okay. And now we have the remote, and turn the power on the remote. The power is now on the remote. I don't know if you guys can see that. So there's no switches or controls on the remote. Everything is done by the main controller unit. So at this time, if I wanted to remote everything is now on. So I have to activate the remote, and now it's activated. At this point, the blade up and down, those are momentary. The problem I had with this particular unit, it came, all the electronics was housed in this. It was all housed in this, the receiver with the relays. There was one board in here. And that board, you had your receiver, and you had, I think, 13 relays, because you had power, around 12 or 13 relays. I don't really remember exactly how many. Let's see, this says there's 13. No, actually there's 10 relays. So we're back. I'm sorry for that little interruption. My camera, for some reason, just stopped recording, and so now we have to pick up where we left off. I'm sorry about that. So, however, what I was saying is that we were talking about the wireless remote, and that there was 10 relays that were on that board. So some of them were latching. No, I'm sorry. None of them were latching. I needed some of them to latch. So now, having said that, the remote, actually this remote box is made up of 4 boards. The board that came out of here, which is just an analog relay board. Each press of a button activates a relay. All share a common feed, and in my case it's plus 5 volts. And the other board would be an input board that senses that 5 volts that's being pressed, knows what trigger it is, which then also at that point it activates a latching circuit which sends 12 volts to a relay that's in here to control whatever on the main controller. If it have to be the water circuit turn on, or the signal to go forward, or whatever, blade up or down. And that's the way I chose to do that. There were other ways I could have probably have done it, but that's the way I chose. However, I still get ideas on, I get the what if syndrome. So now I'm thinking, well, what if the blade breaks? Well, if the blade breaks, the machine is going to keep going through and rip apart that blade will be broken, and just God knows what it's going to break. So I'm thinking about some way to monitor that. When the blade breaks, well, how do I sense that the blade is broken? I can't do it by RPMs because the engine's still going to be turning that wheel. So I came up with an idea. I purchased these 2 brushes. They're from a brush motor. In this case, they're replacement brushes for a washing machine motor. So what I was thinking of doing is mounting these two brushes, I can make a bracket in the back that swings open and then closed again in a locked position. Like say you have the top of the blade here, and after changing the blade or whatever, or putting in the blade, this arm will swing down like this and rest right on the top of those blades. Also has a brush. The blade is going this way. A brush would be for these two brushes, brushing off any debris. So I was thinking about is censoring this continuity between the two brushes. When the blade is gone, well, guess what happens? It breaks that continuity. And that would be, I can build a circuit that senses that and shuts down the main power going to the two main relays for those motors and just shuts the power down. Also triggers another circuit to kill the engine. That I guess I can do that with, it could be a non-latching circuit. It could be a momentary tap on off for the throttle, for the kill switch. The kill switch on the head itself to simulate that switch closing. That's what I'm thinking about doing next. However, I'm going to hold off on that. I'm going to use the machine the way it is right now, and we'll see how that goes. Hopefully, it'll work out fine. I don't anticipate any other problems. It seems to be working so far. So we'll see where we go with that. So until the next time, my next video would be coming out probably mid-April, mid to late April, simply because it's kind of cold out now, the weather's bad, and I don't want to get out there and start milling in the cold. That's just not comfortable. So I'm going to wait until the springtime, and at that point we'll make another video, and I will walk you through everything you saw here outside on that mill, and I can give you close-up shots of what's happening as the machine is going through its motions. So until then, thank you for watching. Have a good day.